Hello everyone, we are from Team KGSC Robocon. We are the official multidisciplinary robotics team of our college. We participate in the National DD Robocon every year. This is our submission video for the Simulink Student Challenge. So every year DD Robocon has a theme. Bots are to be designed to be able to follow the theme, rules and the guidelines. In 2022, the DD Robocon competition was held at New Delhi, India, and the theme was Lagori. The robots were to be designed to be able to hit the Lagori discs and stack the Lagori back again in the order they were placed in. Another additional task of the robot was to displace a ball placed on a stand. We used Matlab, Simulink and Simscape to test the feasibility of our prototypes. We simulated 4 mechanisms in Simscape, namely the throwing mechanism, the ball picking mechanism, the Lagori stacking mechanism and the drive of the robot. Let us look at all these mechanisms in detail.
So now comes the throwing mechanism in Matlab. The main challenge of this project was to calculate the RPM of motors and the angle of the whole mechanism to be stable on the bot. We used Simscape to simulate the throwing mechanism of our robot. The throwing mechanism had 4 wheels which were rotated at around 1500 rpm by the means of which two amp-flow motors were required to design a system to model the contact forces between the four wheels of the throwing mechanism and the ball. We used SimStep multibodies and multiphysics library to import the CAD files of individual parts of our robot. We had to then manually connect all the CAD files to each other to assemble the mechanism with all the joints digitally in SimStep. We use SimStep multibody contact forces library to simulate the forces between the bodies in SimScape. The library had a tube to sphere contact force block which we used to accurately simulate the contact forces between the spherical ball and the cylindrical wheels. The tube,
The drive which we simulated had to travel in a particular L-shaped path in the arena. This simulation helped us to determine the actual acceleration and the forces acting on the drive.
So now comes the ball picking mechanism. The main challenge of this mechanism was to calculate the working of the power window and to calculate the tension in the respective belts which we have used. We used SimScheme to simulate the ball picking mechanism of the R2 ball. The picking mechanism used 6 various pulleys and belts which were run with the help of the power window which made the picking mechanism successful. We used SimScape multibody multiphysics library to import the CAD files of individual parts of our board. We had to then manually connect all the CAD files to each other to assemble the mechanism with all the joints digitally in SimScape. We used SimScape multibody contact forces library to simulate the tensional forces between the belts and pulleys. We attached pseudo-force, pseudo-spheres, which were invisible ones, on the curved gripper made by us and applied spear-to-spear force between the invisible spears and balls to make them come in contact and thus simulate the model. Once both the spheres come in contact, the grips were lifted in upward direction by planar forces in respective directions. Thus, we made our ball picking mechanism successful.
So now let us look at the Lagori stacking mechanism. The main challenge of this simulation was to calculate the force needed to lift the Lagori. We used Simscape to simulate the Lagori picking mechanism of our bot. The picking mechanism used had a pneumatic angular gripper attached to a stepper motor for linear motion in the upward direction. We used the Simscape multibody multiphysics library to import the CAD files of individual parts of our bot. We then manually connected all the CAD files to each other with appropriate joints to assemble the mechanism in Simscape. We added an invisible plane on the gripper. With the help of tube to plane force, we picked up the Lagori and as soon as it came in full contact with the grippers, they were lifted in the upward direction by the planar forces in respective directions. After we simulated the throwing mechanism, we were able to accurately determine the angle of the throwing mechanism to be able to hit the ball placed on the stand. So overall, Matlab Simulink has helped us a lot in our prototyping phases. We were able to test our prototypes without manufacturing them. This proved to be very helpful. This year also in DD Robocon 2023, we are using Matlab to simulate our bots. Thank you.